Okay, so I hope the loop part is clear to everyone. So we'll execute once again here the entire loop part, and now just check whether using the method of moments and using the method of family, what exactly the difference you observe in the parameters. Okay, let us just check. So I have created one vector of 1 cross 4 column and look at the values. Now, can you see the values here?
Yes.
It's this is using method of movements. This is using method of MLE. So almost I'm getting the similar answers. And you also observe using method of moments, using method of MLE, you will get almost same answer. Similarly, here also 31.60, 31.57. So almost again same. So using the iterative procedure, one can get the values of A and B. But whereas if you just observe your theoretical part, you may not getting the alpha and beta directly from the problem. Okay, because here we are getting the equations. So using this equation, considering the initial values of your method of movement, that is your alpha and beta, one can estimate the parameter of your MLE. Okay, that's a one part. So so till here it is the estimation part. Now I just wanted to check whether these estimated values is actually fitting my data. Okay, once you have estimated, now what is the next task? We have to check whether this particular value which we have estimated is that really fitting with my data set or not. So what we have to do, we have to find out the expected value at that point. Okay, so for that we have written here estimates using the each type of estimators. So we are just using the round because approximate 2-3 digits we can consider. Round we are using the R bind. We have all the data together of using the method of movements, using the method of MLE, and using the binomial model. Okay, so we have considered three things here, and we just want to check which model will be better. So here basically it's a comparison of the model. Okay, comparison of model with the help of methods. So look at here, we have the observed frequency. So observed frequency आपका क्या है? ये होता है जो frequency है. Using method of moments, I have to obtain the expected value. So ये मेरा observed frequency हो गया, ये मेरा expected frequency हो गया. See, using the method of moments. Similarly, using the method of MLE, I'm going to obtain the expected value. So here if you observe, I have used A and B. I have used A and B will be initial value. Here I have used A2 B2 is my initial value. Now I am applying here binomial distribution and again n into D binom with 0 to 12 values. I have already number of observations and here P will be a probability value. So P become A upon A plus B. Okay, you can round up to 2 if you want. So you can indicate up to 2 digits. Now you can run it and see. So what you can observe here is, now this is my observed data, observed frequency, and using method of moments, I'm getting, so observed frequency was 2, expected frequency is 2.35. Similarly, observed frequency is 3 and method of moment MLE 2.35. But whereas the expected frequency for the binomial is coming 0.93. तो ऑब्जर्व मेरा इतना है, एक्सपेक्टेड मेरा 0.93 है. सिमिलरली ऑब्जर्व मेरा 24 है, एक्सपेक्टेड मेरा 12 है. सो यू कैन सी देयर इज अ लार्ज डिफरेंस बिटवीन दीस टू वैल्यूज. सो अगर ऑब्जर्व एक्सपेक्टेड में डिफरेंस लार्ज है तो उसका स्क्वायर इज आल्सो गोइंग टू बी लार्ज. So chi-square statistics will give you the very large value. Getting the point? So that's why the chi-square distribution doesn't fit for the binomial distribution. Okay, so chi-square statistics is going to be large. So here my data doesn't suit with binomial distribution. It suit with the beta binomial. Okay, where you can observe the difference between these frequencies. There's not much differences. Not much differences there. Okay, so this means the BB will be the more fitted as compared to the binomial. You can see the plot also. So look at the bar plot for uh, with your X data, actual data. Let's see that how it works. So this is your this is your bar plot with actual frequency, correct? Now what you have to do, you just draw the line here. Just draw one line using BB model and draw one line using the binomial and check what difference you're finding. Okay, so we are so this is my plot. Under this plot, I'm just drawing one line, which is your beta binomial. Okay, with initial values are my AB. Plotted this. So this is my actual fitted value plot. Okay, now you plot binomial distributions. So what you can observe, and this is your legend. So this is your binomial, red one is your binomial, and black one is your beta binomial. Now if you just zoom it this, look at the spread as compared to that it is zoomed. Let me just check it. System is being stop sharing. Just a second, students. Yeah, the screen is not visible because I would find there's some technical with Art Studio. Okay, no problem. You can observe from this plot only. Look at the spreadness of this data set. This is your beta binomial. Okay, this is your binomial distribution. Okay, where you can observe the almost these points are matching. Okay, but here the black one is more spread. It's more spread as compared to binomial because these points you cannot observe actually. So for that, actually, you can check with your either negative log functions, because we have already studied the 2-3 methods, like your maximum of likelihood function you can observe. You can check with AIC, you can check with VIC. So you can check few of them. So let's obtain likelihood some of your log of your beta functions for beta binomial, and you can check whether what will be the maximum values and all. So this you can check. What is the value you're getting? So look at here. So this is your uh, log of negative values minus 12,492. And for binomial, you can check using the p hat is a2 upon a plus a2. So binomial में क्या मिलेगा चेक करो. Binomial में आपको क्या मिल रहा है 12,550. So which is minimum? This one is minimum. correct? Better than the binomial distribution, but actually almost it is same. You can check with AICs also. So कैसे करेंगे AICs में? It's 2 time number of parameter minus 2 time log likelihood, correct? क्या है? What is the AIC formula? 2 time number of parameter minus 2 time log likelihood. Okay, so 2 time there are 2 parameter in beta binomial, so we have 2 parameter minus 2 time log likelihood, comma binomial में 2 into 1 parameter we have minus 2 time LL2, because likelihood functions or binomial we have a 2, sorry LL2. So you can just run this also, you can observe. Okay. Now you can check. So for BB we have a 24,989, and for binomial we have a 25,770. So this is the minimum, and hence we can check, we can say that beta binomial model will be better than the binomial. So this is the way you can compare the model and you can estimate the parameter. Okay. Yes, yeah, it is correct. So in binomial, that is your P is your proportion. Okay, so that proportion in beta binomial, it is A upon A plus B. Okay, see this is that part is already we have, I guess, discussed in the theory part, how this A upon A plus B come. That's, I think you don't have that material, so that derivations we have already done. So if you just say A upon A plus B, and if it is tending to P, then it is a distribution of your binomial. Look at this. So this quantity is basically your theta. Can you see? Okay, so theta is basically your P. So theta follows your the distribution of Y follows your binomial. Look at this. So therefore this P is basically your A upon A plus B. So in that way you can work. I shared this code with you. You can go through that.